Hello? Voila, okay. So welcome everybody. It's 9 o'clock on Monday and it's always difficult. So it's already a success to have all these people here. First of all, I would like to put you a straight question. Who is familiar or who knows what LBS means? That's good. So we have one at least. So LBS stands for Location-Based Services. And the project we are talking about, it's called iLocate, and it's about not only outdoor but also indoor location-based services. The idea of this workshop, it's different from any other workshop usually, the way we think of a workshop, because it will be more of a brainstorming. So we'll be asking you feedback. The idea is that I will go through a first presentation of the project so that you can get an impression of what the project is about, how we are going to deliver, and then we will have a few people coming here on this side, and we'll start a discussion on a few topics. So it's supposed to be very interactive. Feel free to stop at any time. It's not going to be a classroom type of presentation. Now, as I mentioned, the idea of the project, it's indoor and outdoor location and asset management through open geodata. That's a project funded by the European Commission. Actually, what we did when we thought of the project was shifting the focus from just outdoor to the indoor domain. And that's something actually that is not being taken care by other projects. But the truth is that we spend most of our time indoor, be this at work, be this in the offices. We always, according to statistics, spend at least 90% of our time indoor. But the point is that if you think of indoor navigation, there's nothing there. Everybody is used to outdoor navigation, TomTom, car navigation systems. We all know it. It's part of our daily life. But look at this. I mean, this is the example of the hospital that we have, for instance, in our city, in Trento. And that's the guiding you get. Red lines on the floor. Basically, whenever you get there and you need to get to a specific room within the buildings, they say, well, follow the red line until it gets to the end, and then it's the second door to the right. Can we do better than this? Of course we can. And the point is that almost no one knows that actually within your pocket, within your smartphones, actually there is now, in many of them, the power to do the indoor location-based services. And in fact, there has been great attention by well, in terms of recent development by a manufacturer of mobile devices and mobile technologies, Nokia, Google. They are all investing massively on indoor navigation and indoor mapping. For instance, you might have heard of Tango, the new initiative by Google. I don't know if you've heard of it. Tango, it's about a mobile device that will be doing LiDAR. You know what LiDAR is? Laser scanner, as we do it from airplane, but done indoor through a mobile device. That means that as soon as Tango is released, you will be able to walk through the room and 3D scan your room. And then, of course, the point is that you create the 3D model of the room and then you can navigate within the room. So this is going to be a game changer. Indoor location-based services are supposed to be a real game changer. Both Microsoft and Google have been mapping indoor places. I think it's more than 10 to 50,000 places already mapped indoor. We are talking about stations, airports, places that are sometimes indoor and sometimes they are so big that they almost resemble an outdoor space. And again, there is a number of different solutions in terms of technical solution on how to do these indoor location-based services. Technologies based on Wi-Fi location, technologies based on Zigbee, ultra-wideband. There is plenty of them. We will see today that some of these don't even need to use very high-tech functionalities. But the truth is that it's exploding. Now, Apple has just released the iBeacon. I don't know if you know this iBeacon. It's basically a sort of Wi-Fi router that as soon as your iPhone gets close to it, then it's able to give you some context-aware information. The idea is that you get to the shop, you connect transparently to the iBeacon, and then you start receiving information, for instance, on discounts. So again, location-based services are coming, and we don't know that they are coming, but they're there. And if you look if you look at the statistics, I mean, if you look, for instance, at studies from Gartner or other major consultants, you will see that indoor location-based services are supposed to be the next booming trend in the navigation market. Basically, that's after 3D navigation and turn-by-turn navigation. Indoor location-based services are supposed to be the next boom. And they all disagree on figures. They all agree that it will be big. And if you look at the number of companies that are starting now in the indoor domain, they are coming. There is a new one every second week, basically. So there is lots of hype. Nothing has been standardized yet, but there is certainly lots of attention in this market. However, there are a few points, and that's where iLocate steps in. First of all, we do not have indoor maps, or if we do have them, it's a few of them, and it's not clear how we're going to use them, and that's a major point. I mean, this is a community that works with data. Inspire, it's all about data, but if you think of indoor, zero. There is nothing there. No one has ever thought about doing anything with indoor spaces. And again, if we are talking about a private home, then might or might not make sense. But if you're talking about a big airport, an hospital, a station, so shopping mall, having indoor mapping already triggers a few nice ideas in terms of business models and applications, from security to marketing to safety, you name it. So again, it becomes very important. Lacks of indoor maps are, again, one of the major limitations right now in indoor location-based services, and the big market players are responding to that. Google, as I said, Bing Maps, they are mapping loads of indoor spaces, and if you go to the, well, try and look for big airports in the US, you will find in Google Maps you can already see the indoor maps of many of them. That's one. The second problem, the second big limitation, the second barrier is the non-existence of an ecosystem. Think of mapping services, think of GeoServer, think of whatever you want to think about it. There is nothing for indoor. And the problem is that when you are going to the indoor domain, you have the localization part, and there is nothing like a standard or nothing like a toolkit that can be used for indoor location-based services. It's not there yet. Everybody's proposing their own technologies. Apple, they're proposing their own technologies. Google is proposing their own technologies. Several little technology providers are developing their own localization systems, but none of them has thought of a platform to ensure interoperability. And then there is a third item, which is again very important. There is a very limited support for standards. Just an example. Are you familiar with OpenLS, Open Location Service from OGC, Open Geospatial Consortium? That's a standard. It's a service standard. It's a communication standard that gives you routing instructions. Go 200 meters straight and then turn right, for instance. This was thought for car navigation systems. Apply this in the indoor domain and it doesn't work. When you are indoor, you don't say walk 200 meters and take the turn on the right. You say walk out from this room, walk down the corridor, and then take the first door on the left. So even the communication is different. The data is different. Think, for instance, of a road graph, road network graph. When you do outdoor navigation, you have a road network to do navigation on. If you are indoor, there is no road network. So everything has to be re-engineered, rethought in a different way. And actually, in terms of standards, something is happening right now. We will see this in a minute. There is an emerging standard coming. It will be released in a few weeks, hopefully. It's called Indoor GML. That's from the OGC, Open Geospatial Consortium. And it's supposed to be the real big initiative on indoor navigation. So the scope of iLocate. So that was the starting point. So we thought that we could do something when we submitted this proposal by contributing in several of those items. So we said that iLocate will first of all provide a geoportal, a public geoportal. This public geoportal is like OpenStreetMap. I don't know if you're familiar with OpenStreetMap, but we are designing the system in a way like OpenStreetMap is doing in an outdoor domain. We are thinking of the same thing in the indoor domain. Basically, you need a portal where you can, as a public administration or as a citizen, it would be public, upload your own indoor mapping data, modify, structure in the proper way, we'll see how this works, and then publish as open data. So the portal, it's the access point, it's the data repository, and this is supposed to become the European portal for indoor mapping data. That's one. The second one is the creation of a framework, of a toolkit. Actually, we are right now in the final stages of the system design, and we are designing a system that can be used for any indoor location-based technologies, so that you download the toolkit, you plug in your own technology. If you don't have a location-based, if your technology is not supported, you can extend it because it's an open source domain. And there you go. The idea is pretty simple. If you connect to iLocate, no matter if you are using your GPS when you are outside or a Wi-Fi connection where you are inside, you should be able to move sorry seamlessly, move from the outdoor spaces to the indoor spaces without being aware of it, and the system should just work. That's the basic idea behind it. Sorry. So this open source toolkit will be free to download, and it's scalable. Is based on a sort of plugin approach, so that it can be extended to provide more functionalities, support more location technologies. Then extension of current standards. As I mentioned, standards are getting there. We are close to the first release of indoor GML 1, but we are already planning through iLocate to contribute to 1.x or 2.0, so definitely we are going to actively contribute to the extensions of the standards. And then this is not a research project, this is a pilot project, so we'll have to develop something that works. So we are going to develop a few final applications. So besides the server technology, the middleware, we are delivering also the applications for people to use these systems.
Giuseppe?
Yeah.
In terms of data model.
Yeah.
You mentioned that there are already, I don't remember how many, tens of thousands of indoor spaces already mapped.
Yeah.
But are they using some internal data model? Like
Google's.
They started
Google's.
with Collada for the 3D.
Well, right now, as far as I know, to the best of my knowledge, the only really massive initiatives are from Google and Bing Maps, and they're just doing the way they want to do it. There isn't anything very structured, in the sense that the point is that when you step indoor, you have different requirements from outdoor. For instance, you want to qualify rooms, spaces, according to their semantic meaning. You want to know that that big space is the check-in area, and the other big space is the waiting lounge. These are things that are not standardized in any means. Basically, what you see if you go to Bing Maps or Google Maps, you can see you can see the shapes of the building. There is no way to qualify them. There is no way of tagging them in a standard manner. This is going to be a big problem, and that's one of the things that we...
Okay, honestly, I never went into these new functionalities of Google, but you mentioned some of the US airports.
Yep.
But I guess they are some basic functionality of navigating without any routing or any semantic behind.
Yeah, you can navigate, you can certainly find your position. I mean, most of the new generation mobile phone now support GPS. I mean, if you are inside, it wouldn't work perfectly, but by using triangulation with cell IDs and Wi-Fi, you're already able to locate yourself in indoor spaces with an accuracy of 10 meters, 5 meters. If you are within a big airport, that's probably enough. If you need to know to the check-in area, check-in or to gate 22, probably gate 23 will be more than 10 meters apart from gate 22. So again, that kind of resolution is already fairly usable and fairly ready to use for people. And that's exactly the point. You have this mismatch. So technology is there, but at the same time, the culture is there. That's very important. From the cultural point of view, we are all used to use navigation systems. In fact, every time you enter a shopping mall, probably you would like to keep on using your navigation system, but at the same time, the ecosystem is not there. And when I say ecosystem, it's not only about hardware, it's about the platform, but about the data, again. So there is a mismatch. And that's where it's all moving very fast. This market is moving very fast, but that's where there will be significant interest in the next few years. The scope. So as I said, the domains of reference, we are going to test the system and develop applications in a number of domains. Essentially, it's two big areas. We are moving within the health domain, for instance, a clinical path. So you have to check in for a one-day exam at the local hospital. The idea is that the app will be able to guide you from the doorstep of your house to the doorstep of the room within the hospital where you have to undergo clinical checks, and then help you all the way throughout the day to go from room A to room B to room C and so on. So that's sort of navigation. And then smart tracking and asset management. That means that if you attach a tag to a device, for instance, in the case of medical equipment, then you can move the pieces of equipment all around the hospital or anything around the space and being able to find them. That means that, for instance, when you do asset management of maintenance, you can have even new management models. You can share equipment better if you know where they are. For instance, hospitals are trying now to reduce cost, cut cost by sharing pieces of equipment between different units. And of course, you can do that only if you are really if you are really sure to be able to know where the different pieces of equipment are. Just an example, as a company, for instance, we have developed indoor location-based services, and one of our customers at some point was a company doing maintenance of medical assets. And they said that they went into the hospital and they had to maintain 100 infusion pumps. If you don't know what infusion pumps are, these are little boxes like this. They cost between 500 and 2,000 euros, and they are used to, basically these are used to put you medicines in your veins in a controlled manner. These are not critical equipment, but they are not too expensive by medical standards, but there is plenty of them within the hospital. You're talking about tens, if not hundreds, in a big hospital. Now, if you are a company and you want to maintain them, please come in. If you are a company and you want to maintain them, you need to find them. And they said that they had planned they would do 10 a day because it was a reasonable schedule. The first day they only found 2 because this little piece of equipment, they are everywhere in the hospital and you don't know where they are. So that's the real problem company needs to face. That's why it's so important for asset management.
How do you qualify the equipment so that you can identify it?
In this case, we attach a tag to them, an electromagnetic tag. In that case, in that case was Zigbee, actually. It's a small unit based on Zigbee, and it has battery with an accelerometer. So where you're not using it, it just goes on sleep and then this deep sleep. And then as soon as you take it, it wakes up, updates the position, and then again, you have some antennas everywhere in the hospital, and then you can localize it pretty accurately. We are talking about tens of centimeters or a couple of meters, depending on how many antennas you have. That's more than enough, really, to find an object. For instance, I don't know if you're familiar with the ultra wideband technology, UWB, for instance. This is the next big thing, probably in the indoor location-based domain. We are talking about something that will be able to find, to locate things, so antennas, tags, with an accuracy of few centimeters. We are talking about 5 centimeters, 5 to 10 centimeters, within a range of 500 meters indoor. That means that you can have only really a few antennas per building and still being able to localize things or people with an accuracy of 5 centimeters. Within an area of 20 meters radius, you can have up to 20,000 tags because the system scales up very well, something that, for instance, Bluetooth or Wi-Fi doesn't do. So this ultra-wideband technology that has been explicitly designed for indoor localization systems will be probably the next big thing. Just to give you an idea, Wi-Fi or Bluetooth that, for instance, are used for localization weren't born to do that. The idea of Wi-Fi was to transmit data, the idea of Bluetooth was to connect your headsets to your mobile phone, and the idea of Zigbee was to provide some machine-to-machine technology communication channel. They were kind of adapted to be used as localization technologies, but they weren't born as such. Instead, ultra-wideband has been specifically designed from scratch to do localization technology, so a different story altogether.
And the tags store all the information about the assets themselves?
Sorry?
The tags store all the information about the equipment?
Yeah.
So
Exactly. The idea is that you have once you have a unique ID, then you're done. Basically, it's your registration number. You attach the physical tag to the object, and that's all you need. Once you get there, exactly. But for instance, some of these technologies, for instance, UWB can be also used as a communication channel. I think you get something like 4 to 6 megabit per second. So not too bad. That means that if you attach it to medical devices that can send out information, then you can use it to send out, I don't know, alerts or whatever, logging information. So again, it's a game changer. And the target price for these UWB tags is set to be in 1 year as low as $5 per antenna.
But then you need some costs of, let's say, infrastructure to put not just the tag on the object to be tracked, but also
very true. But when you are talking about, for instance, $2 to $5 per chip, then maybe with the board it will become a little bit more. But it's something that you will have in your pocket in a couple of years' time in your mobile phone. So if even the antennas will become extremely cheap. They are talking about next generation routers and gateway like Wi-Fi gateway to have already UWB embedded within them. So again, you can see how this is moving fast. Or for instance, most of the new mobile phone already have NFC, near communication technology, for instance, to make payments just by swiping your mobile phone next to the machine. It's very likely that the same will happen with UWB. So again, you can expect to have that sort of development in a few years.
Frequencies are microwaves.
Yeah, we are talking from 4 up to 10 gigahertz. So it's let's say high in the spectrum. And again, it will be a game changer, and will also enable new things, like for instance relative location. So if I have a UWB localization system in my mobile phone, and then you have one, maybe we can localize relatively to each other, maybe not absolutely to the world, but that's probably enough. I mean, if you want to localize your kids, and you have a mom and a dad, and you know that the kids is there, that's enough. If you see what I mean. I mean, again, it will change completely the paradigm to the localization as we know it right now. But this is just one example. What I'm saying is that it's a very fast evolving domain, and the large community knows close to zero about it. So it's something very fast that is about to come, and we're not prepared as a community to get there. That's the feeling that we get from iLocate. Then objectives. As I mentioned, the first objective is to create this virtual hub. The idea is to create a portal. The portal will be used by airport manager, public administration to upload their data. Simply imagine as I mentioned, an OpenStreetMap for indoor data. In fact, we are talking to the OpenStreetMap community right now to make sure that we can also dialogue with them, establish a dialogue, and possibly join forces with them. It doesn't make sense to have different things at that point. Then we are not talking only about public buildings, strictly speaking, but generally speaking about publicly accessible building. A shopping mall is private, but still it's accessible publicly. So you definitely want to know that. Again, just to give you an example, I don't know if you remember a few years ago when Google released their G1 Android phone. That was the very first Android phone. There was a competition about thinking of the best new business model. And one of the apps that actually won was very, very simple. You could scan with your mobile phone with a camera. You could take a picture of the barcode of the product you liked. Say it was a camera. So you get to the shop, I like that camera, I scan the barcode. The system reads the barcode, it knows that that's the camera you like, and stores that piece of information. Then 2 days down the line, you walk past a shop, and the system tells you the camera you like, not just the camera that you like, it's now on discount today for, I don't know, 20% off. It's a very simple idea. If you think about it, it's very simple, but it was limited to the outdoor domain. Now, if you move into the indoor world, you can start thinking of how many new business models can be enabled by indoor location-based services. And in fact, market analysts predict that the single biggest driver of indoor location-based service will be what they call ultra-local marketing. Basically, you walk past to a shop and it says, come in because the things you like are cheap now, or that's also very local advertisement. For instance, right now as a company, we are discussing with retail providers that they want to have this sort of, exactly this sort of services. So we as a company, for instance, we are already asked for it. So the market requirement from the real world is already quite strong. We can feel it as a company, let alone as a... So the idea is that this portal will become the single point of entry to data, and we are talking about open data. And again, this is very important, because if you want to have this snowball effect, you need to have open data. The example of OpenStreetMap, I think, speaks to everybody, that the impact that has had OpenStreetMap has been enormous, because mostly, I'm not saying only, but mostly because of its open nature. So that you can download the data set, or you can use it as a service, and then again, on top of this, you can create any business model you want. So again, it's an enabler to services. Yeah.
If a business owner has his data in CAD format, the footprint, let's say, of his shop, will be able to upload his data to the portal, or he has to transfer it to change it in open format?
Well, the idea is that the portal will provide a set of services that can help you migrate from CAD to CityGML and create also the indoor GML structure. And then eventually the final data that will be created will be public and open. So that's the most important thing. But again, think of iLocate. There will be a reference of iLocate, an instance, a service running to the public, but the idea of the toolkit is that if you are, for instance, an airport manager or an airport service provider, you can install and run your own instance of iLocate. So don't think of iLocate just as a one repository in the public domain, but it can be, again, many repositories. So as I like to put it, it becomes a kind of indoor counterpart to OpenStreetMap for indoor spaces. Then objective number 2, this is about... Sure, yeah.
So you talk about CityGML. Will it be the internal format of this virtual hub?
Yes and no. I mean, it will be both. Now, let me be a bit more technical. Are you familiar with the CityGML?
Yes, because I was facilitator of STEAM in-spice in building,
okay.
And we had a 3D model based on CityGML.
Right. Are you familiar with indoor GML?
No.
No. I'll mention this later on, but to cut it short, Indoor GML does not do the building part. Indoor GML, it's all about navigation, and it's all about the graph, so to say. We'll see this in detail. Think of the street graph, the network graph that you use for outdoor location. Indoor GML provide that sort of facilities within an indoor domain. And it has been specifically engineered to do that very well in indoor spaces, so that whenever you step out of the indoor spaces, then you connect to the outdoor infrastructure. And there is a very elegant way of switching between indoor and outdoor, of course. So that's where it stands. On top of that, indoor GML refers explicitly to CityGML. So in other words, if you want to qualify a room, you use CityGML. And the idea is that you do not need to reinvent the wheel. If there is CityGML there, let's use it. And in fact, it's not only that. Indoor GML is a little bit more flexible than this, because you have the double option. You can either refer to indoor GML features, or you can refer to IFC, which is industry foundation classes, basically. So depending on where you stand. There is a big discussion at the OGC level to provide a unified model on top of both, because at some point you can see that CityGML is providing up to level of detail 4, it's very detailed, and someone now is talking about level 5, there is lots of debate about it, but at the same time there is IFC coming from the other standpoint, from the engineering, from the CAD domain, so there is a convergence at some point, or maybe not. So we are talking about also a unified model sitting on top of it too.
But LOD 4 or 5 are related to
inside the building. Yep. So with LOD 4 you get basically to the point that you can enter, you can describe doors, windows, walls, you have that sort of features.
From inside.
From inside. So it's a model which has been, it's a building that has been modeled completely indoor. The added bonus of IFC is that you know that that window there is made of a wooden frame, and it has that very little nodal. You need that sort of engineering feature. You don't get to that detail with the CityGML. You get to that detail with the IFC. But again, indoor GML basically provides you the pointer so that when you need it, you can either refer to classes of indoor GML or classes of IFC. It depends on what you're doing. In fact, in indoor GML, you could also represent your room as a simple curve or surfaces if you're working in 2D or 3D, but it wouldn't be very elegant. So there is basic provision for defining shapes, but you better refer to CityGML, and it's just more elegant. So to reply to your answer, yes, we will support CityGML, but for us, CityGML basically will be the scaffoldings of the buildings. So the way we will represent the building. So there will be support for CityGML because we need to represent the building, but the navigation itself will be done on a different standard channel, and that's indoor GML. So we use CityGML to represent the object. That doesn't really matter whether this is 2D or 3D. And then indoor GML is being used for the navigation part. And the navigation part is not easy because within indoor spaces you have floors, you have hybrid spaces. This is a room, but outside is a corridor, which is a transition space. So you have concepts which are again very interesting. We will talk about this in the reminder of this workshop that needed to be a different data structure, and that's why indoor GML kicked in basically. So objective number 2, which is this is the development of the infrastructure, the true infrastructure. So that's the software, that's the platform. Again, developed as open source. And the idea is that you have, let's put it simple, you have a communication layer, and then you connect to your different location technologies, be these GPS, Galileo, Wi-Fi, Bluetooth, ultra-wideband. We just define a common protocol that, by the way, is based on an ISO standard. And then you just, through open specification, if the location technology you are using is not supported, you just develop the extra plugin that you need, and then the infrastructure provides access completely transparently to location information. Again, regardless whether you are indoor or outdoor. So the concept is very simple. You connect to iLocate, and then you're outdoor, you're probably relying on GPS. As soon as you enter, you are relying on Wi-Fi localization, maybe a little bit of GPS if you're next to the door, but you don't need to know it. I mean, the system does it automatically for you. That's the basic idea. So from a technical point of view, we have this communication bus that provides the abstractions where you have functionalities like the location, like the routing. There is a part of crowdsourcing, but I'm not going into this in detail today. And then there is the indoor and outdoor data structure. And then when it comes to indoor, that's what we have discussed so far. The outdoor part, it's OpenStreetMap data, road network from OpenStreetMap. Then in case, for instance, of other scenarios, for instance, the asset management, then you also have other asset management modules, but they basically rely on the same communication structure. Again, if you have a tag attached to an infusion pump, to an object, it's almost the same. The navigation module is the same because the engineer needs to get from here to wherever the piece of equipment is stored, and then from that point on, the asset management starts. But as far as the navigation and location, it's exactly the same thing. So talking just a little bit about the technology, that we are going to create a toolkit which will be very general and extendable, but of course we will start from some technologies for the pilots, at least to test the system. And we are going to support a few of them. One is Coupa, which is based on, it's a kind of a spin-off from Nokia, and it's based on Bluetooth 4.0. It's like iBeacon. Similar to iBeacon. So again, indoor location technology that can provide accuracy down to a few centimeters. For instance, Coupa is being used to track position of football players within a soccer field, and you can see them moving in real time. At very high frequency, we're talking about 50 to 60 hertz, so you can really see people in real time moving back and forth. Another one, for instance, that we are using is based on Zigbee, the one that I was mentioning that we are now using, for instance, in a hospital. It has the advantage that the battery can last up to 6 years because the system is not continuously transmitting, it only wakes up when you move it. And then it has other advantages. And then there is the Wi-Fi. If you look on the web, you will find plenty of solutions based on Wi-Fi to localize you when you are indoor. You're talking about probably 10 meters accuracy. One of these is Kahoot, there is Combane, there is plenty of them available. But again, we don't want to go in the details of each single technology. The idea is to provide an abstraction layer on top of these technologies. A common language. So this toolkit will be based on open standards. You might have guessed that we are very keen on providing support to standards, because if we want these technologies to become usable, it has to provide support for standards. So CityGML, Indoor GML, and the like. And the idea is to develop a toolkit that can be literally downloaded and used by anyone and extended. The client will be also developed because we'll need to test the systems. And one of the things that we are really keen on is to make a system secure. We are talking about location of people, preferences of people. Basically, you know everybody. You know everything about that person. So the system and the entire infrastructure has been designed with security and privacy in mind. We follow the privacy by design approach. It's a new philosophy to software engineering that basically makes sure that the entire system is from scratch designed to be privacy sound. If you do it later, it's probably too late. And then, as I mentioned, leveraging on plenty of standards, but we can go into details later if someone of you is interested. Now, this project is not a research project, as I said, it's a pilot project and an innovation project. The idea is to take existing technologies, merge them all together, integrate them all, they're all there, and test them in real operational scenarios. And this is going to last for 12 months. And basically the use cases that we are addressing are the guidance of patients through hospitals, the smart tracking of asset equipment, as I mentioned before, and visitors, for instance, going to a museum, going to a public office, so general guidance within buildings. And we have plenty of pilots. Now we are at 15 already, and we have received a request to do more pilots even from external stakeholders. So we might end up with some 17 or 18 pilots by the end. We are ready to that. Which is a big challenge, because these pilots will have to be operational for 12 months within real operational scenarios with real users. So the first one, let me go through quickly. It's an hospital in Rovereto, that's where we are based. So guidance of patients. Then we have another hospital in Malta. As you can see, there is plenty of hospitals for obvious reasons. I mean, this becomes very important to them. Then we have an hospital in Athens, next to Athens. Another hospital in Alba Iulia, Romania. Then another hospital in the Netherlands. Then we have a house for the elderly in Romania. And we are also doing another one in Italy, by the way. This is very important when you're talking about patients with Alzheimer's. They start wandering around and you lose them, so it becomes again important. Dresden, Germany, that's a university, how to help students get to a room. Some of you might have had a problem today, so that's exactly the use case. I can see people laughing. So that's the use case. Then Rijeka, Croatia, that's a number of buildings from the municipalities. You need a certificate somewhere in town and you know where to get it, so it will help you go right to the office. Brasov, Romania, same thing, public offices, how to get from A to B. Genova, the big skyscraper there, same thing, how to help you get to public office. Velletri, so it's another municipality, same story. Then we have a business park. It's a big business park in Luxembourg, and you have similar problems. You want to go and find a company and you don't know where it is inside the business park. Then we have a museum in Romania, that's Brukenthal, and it's a multi-site museum. The museum is scattered in 10 different locations around the towns with different collections. And the idea is to have a cultural path that is going from indoor to outdoor continuously, seamlessly. And then we had an open call last year and for a new partner and a new pilot, and we got it. And that's a completely different pilot. That's a street, a road segment in the north of Italy, which is pretty peculiar because it's at the bottom of a canyon. So it's the example of outdoor space that becomes indoor somehow, because the GPS is not working, you have plenty of tunnels within that road, so we will be using cameras to locate vehicles in real time and provide information on if vehicles or people stop there, for instance, in case of emergency. So again, we are stretching the concept of indoor and outdoor. What is indoor and what is outdoor? And the idea is to pilot them for a duration of 12 months. So they will be operational for 12 months. And then maybe, Giacomo, you want to spend a word on this?
Yes, it is. We strengthened since the beginning the opportunity to establish cross dissemination activities with the network of SMIS5, which is another 27 project, which basically established a network of almost 600 stakeholders, most of them small and medium enterprises active in the geospatial domain. And there is a big interest for these, let's say, more traditional companies to explore.
You. Hopefully we have triggered a few open questions. I have some slides that are sort of a thin red line I will go through. So I will asking questions to some of the partners which are involved in the consortium as an open discussion, but really now it's also, I would like you to keep to ask questions. It's supposed to be very interactive, so feel free to discuss with us. Now, let me just introduce those who are involved so that you know who is who at least. So we have Sabina Dimitriou from Urba Sofia. She comes from a urban planning background. Then we have Giorgio Saio, GSIG, Italy, coordinator of GSIG, which is an association for geographical information system and coordinator of several European projects. I just cut it short, otherwise the list will be too long. Then Wendy Laura Zinta, again, urban planning background. Then we have Jacopo Bartirano, the SME man, small and medium enterprises man. And then we have Alkis, who is the engineering guy. So the bad questions about technology go to Alkis and to myself. And I am the CTO of Trilogies, that's a small company, small and medium enterprises in the north of Italy, and I'm the coordinator of iLocate. Okay, enough. Let me open the new slides and we start. Okay, so this session actually is the second in a row. We had the first one a few months ago. It was extremely successful. We had almost 100 attendees. It was at 9 o'clock on Monday. So we discussed about the concept of location-based services. That's where we started from. At the beginning, the project was just beginning, so we didn't know where we were going somehow. So we explored a few aspects of indoor location-based services, as I mentioned today. Then we also discussed some implications of this in the big framework of smart cities. If you think of smart cities, again, it's always outdoor, but if you think of indoor location-based services, then you can relate to the indoor domain as well. And certainly we found out that in terms of opportunities, as we might have guessed today, there is plenty of them. Plenty of opportunities coming from a new business model that can be started, and new services that can be started through indoor and outdoor location-based services. And the initial discussion we had, and that's where I would like to start now, it's the difference between indoor and outdoor. Is that clear? I mean, sometimes this might not be exactly clear, and in terms of data modeling, this has got even implications. For instance, this is the biggest fun park in the world. It's located in Japan, and this is 300 by 100. meters. So you have waves, you have an artificial beach, and you have an artificial sky. This is a covered roof. Are you considering this indoor and outdoor? So again, it's very personal. And then the other point we started from, and then I will let you the word because I would like Sabina to start off with this. It's the concept of private space, because when we are talking about indoor, there is a private space around us, and this private space moves with us. And this has got implication in terms of location-based service. I love this picture because it really gives the idea of the space moving together with you. Now, I would like Sabina, first of all, to start discussing about the hybrid or blended space from the standpoint of a urban planner.
But first of all, I have a question. Is there anyone here who's a planner or an architect, or working with a planner or an architect, by any chance? No.
Lucky you.
Well, yeah, of course. Now, actually, what we do is design space. And space is basically an extension of the activities that people undertake. In the city, there are thousands, literally thousands of different activities. And recently, these activities have become to change, and space has to adapt and change with them. We're not talking about the classic office building anymore. We're talking about layers and layers of different activities, and the more success a space has, it's directly linked with the capacity to accommodate different activities, to accommodate layers of activities. Maybe in the morning this happens, and then in the evening we have a show or a temporary activity. And these are all things that could become very much of interest and could become localized through this type of technology developed. And now, last week, for example, I was in London, and two things were really interesting to see and to walk through. The first one was the Canary Wharf, where this was basically a succession of indoor and outdoor spaces. You could literally you were just walking, and if you thought of something else than the surroundings, you were not capable of figuring out whether you were indoor or outdoor, because this is a connection of indoor and outdoor spaces that work seamlessly. But if I would have used my cell phone or my tablet to search for example, a bus station or a point of interest to go get a coffee, for example, I couldn't have. And this is a service that I think is very much needed. And the second one was the Barbican, where you have literally these pedestrian highways through this huge structure. And this is indoor, but it's also outdoor. And these are two examples that I think speak for themselves as indoor and outdoor spaces. These are hybrid spaces. They're connected to the street, and they're connected to the inside of buildings, and they offer different functions. Now, hybrid or blended spaces such as malls, they offer a lot of different activities, and these are not compact spaces, these are wide spaces. For example, I'm entering a space, I'm looking around, and if I'm in a mall in Romania, where I'm from, I'm completely lost. I spent probably 45 minutes looking for a bank that I knew was there, but couldn't find it. Sure, we have maps, but the importance of having something dynamic in your pocket to guide you from your current location to the location of your destination is really, really important. What next?
Let me jump straight to a bit of a focus on indoor GML. So none of you is familiar with indoor GML. Is that correct? Any of you has ever heard of it? Noted then. Okay, I was planning to do this later, but I'll skip to the point where I introduce a little bit indoor GML because I think it provides some background, technological background. You want to say something? Okay, sorry. The point is they don't know what they will be asked. So it's exactly, it's really in real time.
Okay.
So you're okay, okay, you will hate me. So indoor GML starts from a simple concept of navigation. When you are outdoor, you have the graph, the route graph. And this is, do you know what a route graph is? Sorry, maybe I give it for granted. Anyone of you not knowing what a route graph is? Yeah. Road network? You know what a road, okay, good. So the idea is that within indoor spaces, we do not have a road network, of course. So first of all, the first thing you do is that you define spaces, you qualify spaces in a semantic way. For instance, you have staircase is a transition space. This is an interesting concept also from the urban planning point of view, where you formally define it as a class, which is a transition space. And then this transition space class is attached to a CityGML model of a staircase and of the room. Then other transition spaces, hallways, for instance. Then you have connection spaces. Connection spaces are spaces that are actually connecting from a room to another. For instance, a door. A door is a connection spaces, or you have a connection boundary, which is the wall connecting the two rooms. And then you have the general space. The general space are the rooms, if you like. So this is the semantic groundings of indoor GML. Most interesting, you have what is called the anchor point. And this is something that I would like to discuss also from a philosophical point of view, if you like. The anchor point is the connection between the outdoor world and the indoor world. Basically, when you get to the anchor node and then you have an anchor boundary, you disconnect from the routing system outdoor and you connect to the routing system indoor. And again, the definition of this can be, or may be, very sharp. You enter an airport and then you swing indoors and you're in, or it might not be that clear in some cases. So that's the general understanding of how it works. Then let me put a very nasty slide, but that's all. I'll swear. I promise this is the only technical kind of slide. The idea is that if this is the topographic space, and these pictures, by the way, are taken from the documentation of the standard. I acknowledge them. This is not our slides. So if you start from a topological space, then you have a cell. A cell is the counterpart of a room, if you want, in indoor GML lingo. You have a cell, and then you have another cell. Those two rooms they have an adjacency relationship. They are sitting next to the other. So if you look, for instance, at the graph, you can have the room number 1, which is a cell, and the room number 2, which is another cell. And then you have a graph connecting the two of them, which is the wall, basically, connecting the two rooms. This duality that you go from a surface or a curve, if you are in 2D, a surface if you are reasoning in 3D, to a point, is called Poincaré duality. So it's all based on this Poincaré duality. And again, the connection that you have is a hard connection, because again you have, because in this case you have a door, or it can be a dotted connection because it's a wall. So in the end, what you get here is navigable edges, for instance a door, because you can navigate through a door, or non-navigable edges, because this is a wall, or it might not be a wall, it might be a fence, or it might be a pool, it might be a laser beams, whatever, but it's something that you cannot get across. So that adjacency graphs already provides you lots of information. Then look at this. This is very interesting. The room 2, it's connected to the external domain, to the outdoor world, which is anything else, basically. But at the same time, also room number 1 is connected through a non-navigable edges to the external world, because there is no door to the outside world. So you can see that this becomes a very elegant way of building something which is a graph, which is, yeah.
Now I have a question.
Yeah.
Having said that, I definitely lack in deep knowledge of technologies behind, but because I'm more, I don't want to say expert, but I know more about data modeling. I don't see any problem in guaranteeing the seamless navigation through indoor systems from the data modeling point of view, because here there is the solution. It's just a way to implement in connections of databases and so on. But for me, I don't see at all how the technology can, because if I arrive until the airport with the navigation system of my smartphone using GPS, yeah. And then I can imagine quite easily how the database supporting my from A to B, where B is the entrance door of the airport. Then I can imagine that there is another database of data modeling everything inside the airport. But how my smartphone can switch automatically when entering into the door, recognizing that the position, my position, which is the key point of routing mechanism, can be provided by completely different technologies. This is for me totally unclear.
Now, from this becomes very technical, but the idea is that you connect to the iLocate service when you are already outdoor, and when you are outdoor, iLocate works pretty much as any other application. You have, for instance, OpenStreetMap graph to route you, and your GPS position.
Connecting to iLocate, what does mean? You have to
run an iLocate. You run an
app.
app. Exactly. That connects to an iLocate service that provides you the routing. So the routing is not done locally, but it's done on a remote server, as it is done, for instance, with Google. When you use Google, your Google navigation, is done remotely. It's not done locally. Or the routing is done remotely, but then the navigation is done locally. So the instructions are calculated, are played locally, although the route has been calculated on the server. And it's exactly the same concept. The only difference is that this service will not stop when you get to the indoor domain, because it will switch to the other graph.
So before to enter into the indoor, you have to activate your app.
If you want, yes. Or when you are indoor, it's the same. If you are indoor, it will work anyway. So the point is that you will have one app, and the app, whoever will develop the app, will refer not to a standard navigation service, but to an iLocate navigation service. At that point, that app will work both indoor and outdoor. So it's a very simple solution to a very complicated problem, in principle. Then, from a platform point of view, it becomes very complicated.
The important part, if you permit me, is the anchor node, because the anchor node transforms the outdoor coordinate system to the exact, let's say, indoor position. So it's a very basic point when the coordinates start to be transformed into the GML.
Exactly.
And then, if you know that point, and this could be the, let's say, the 0 point, in order to start metering the distance that the person can walk. So in the indoor area, you do not have the exact coordinates, the
Absolutely.
Yeah, the WGS coordinates, but you have 10 meters left, distance, or distance, or 20 meters up if you are in the first floor and the second floor.
The beauty is that you can, this way you can keep on using your local reference system when you are indoor, but at the same time there is always a way to trace it back to the global. Because
again, for me, I can easily imagine that there is an algorithm, even sophisticated, to take all these things into consideration. For me,
but it's not as much a problem of an algorithm. It's more a matter of how you structure the data. Really, yeah. So let me get back to this, because then I would like to open a discussion with you being involved. So the adjacency graph basically tells where is where and what is connected to what. But then from this you can add the connectivity. So just remove the non-navigable spaces and you get the connectivity. So that's the closest thing you can get to the road navigation graph. So you know that from room number 1 you can get to room number 2, and then from there you can get outdoor. Now, question to you. How do you define those rooms? Because the problem is that if I am within a shopping mall, a room, the big area is just one. Or think of a supermarket. You have, technically speaking, you might only have a big, huge room, but definitely you want to deal with smaller spaces. So there are problems of subdivisions, and these are supported, by the way, in your GML. Then something that I would like you to think about is the connectivity. Think of that door. If that door were 60 centimeters, that door within our connectivity graph, if you are talking of walking mode, would be connected. But if I'm on a wheelchair, that door is not usable by me. So if I have the walking graph and I have the wheelchair graph, then the wheelchair graph will not have a connection between those two rooms, because the guy on the wheelchair will not be able to go there. If there is a step, for instance, there would be a connection in the walking graph, but there won't be any connection in the wheelchair graph. Now, start thinking of domains. You can have a walking graph, a wheelchair graph, robots. Think of robots.
Building a bit on what you said, actually, well, using this graph, or having this graph, the benefits are, we don't even have to mention them for the users, but also for the designers of space, basically. This tells a lot of actually tracking and seeing how people move through a space. It offers really a lot of insight into the common navigation paths. and whether they're sufficiently dimensioned, and whether the doors are sufficiently dimensioned, and whether that particular building offers the necessary functions for differently abled, or for elderly, or for the blind, for example. And this is also a very important point that's of a big interest for planners, how to feedback on the information that we take through this app in order to better the spaces, in order to redirect people to points of interest, or to move points of interest if they're not on the common path, if it's difficult for people to get to them. And actually this will definitely improve the way we use space, and it will definitely improve the quality of space.
For instance, think of another issue. You have the graph, but this would be a time-based graph. That room can be entered from 8 to 8, 8 in the morning to 8 in the evening, but not from 8 in the night to 8 in the morning. So not at night time. So again, you could have different graphs according to your different times of the day. So imagine how many graphs can you build and structure them in logical layers. You could have robot navigation. Can you think of different locomotion ways? I don't know, if you are in the airport and you're using the golf cart, there are areas that are accessible by the golf cart, or areas that are not accessible by the golf cart. So it provides an enormous power. I mean, you were referring to CityGML. Can you see now how different it gets from CityGML? Which is your point of view about this?
I am discovering it.
Right. It's a completely different way of looking at the indoor space. In fact, the beauty of this is that you can also think of rooms. So these nodes can be rooms, but might not be rooms. In other words, for instance, think of an indoor space where you have Wi-Fi hotspots, and these Wi-Fi hotspots are used for navigation. Then you have the coverage area of each Wi-Fi hotspot. There is a surface. Each of them can be considered as a cell, like a room, and then you do navigation based on the cells, following the cells, to make sure that wherever you go, you are being tracked. So again, it becomes very difficult. I mean, it becomes very complicated in the way you have to structure the data, but it becomes very powerful at the same time in the way you can define and create services. Now, back to the questions. So, again, the concept of indoor or outdoor, because sometimes now you are left with the point that what is indoor and what is outdoor. Is the balcony outdoor or indoor? Is it a terrazza or a veranda, as we call it in China, indoor or outdoor? Again,
it's an in-between space, actually. We don't attach these tags of indoor and outdoor, because there are even, say, architectural buildings that start to blend indoor and outdoor on, say, 50 meters, and they just start to blend the indoor and have some outdoor coming in, and maybe have a garden inside, and this is also indoor and outdoor. The interface is pretty transparent there. And this is why, from an architectural or an urban planning point of view, this is not essential. What's essential is the function, and what's essential is how people use that space. Not in terms of indoor or outdoor, but in terms of a playground or information point or smoking lounge, or these are the spaces in which people conduct some activities, and they have to be designed in order to incorporate these activities and in order to offer the necessary services to the people there.
And that boils down to the data structure in the end. The point is that there is not such a thing like a standardized way of qualifying indoor spaces, which is something that we are now lacking, and that's where I wanted to get. The point is that we are used to qualifying outdoor spaces. We have a land coverage map outdoor. So what about indoor, for instance?
Well, I can tell you that the function map for the urban planners, we have it pretty simple. In most countries, you have the buildings, and for the buildings, you attach some tags and say the height is important for us, the contour of the building, but that's also, the building can have, its contour can be different for different levels, and this is also something that boils down to leveling, and the vertical representation of space, which on a map is not visible. and we're trying with dotted lines, but it's really not a finesse representation. And the function, and for the functions, usually we have what is called mixed use. Oh, that building is a building with offices and a cafe and a restaurant and a lounge, and that's mixed use for us. But it's really important actually to differentiate vertically these functions, because these functions all require something different. For example, you have a cafe and you have a lot of people coming in, and you have maybe a capacity of 200 people there consistently going in and out, and you have to then dimension it. The dimensions of the doors should be properly connected to this ongoing in and out and in and out. Whereas in the other part of the building or the upper levels, you have offices, and there's a different need for urban and architectural features. So this is really important to us right now. Really important. We don't have the tools, we don't have the standards to differentiate these.
But may I ask those of you working with CityGML and Inspire, you mentioned that, is there anything about classification, and any thought about classification of indoor spaces going on at this moment?
We have of course some code list in Inspire model, but these code lists are very, very simple. And you know as me as the code list in CityGML, they are not harmonized code lists, they are just code lists coming from German cadastre.
Yep.
So the Inspire code lists are really very simple and very oriented to environmental purposes.
But that's where I think there is really lots to do. There has been an American initiative on defining semantically a common, well-acknowledged way of representing indoor spaces in terms of semantics. This can be a classroom, which is a subspace of university, which is a subspace of educational buildings. You know what I mean? That sort of taxonomy, it's not there. There isn't such a standardized way of structuring it.
It may be difficult, for instance, when university hospital, I think the classification of CityGML works rather well with the notion of room. In an airport, it's not so relevant. Yeah,
but the point is that now with the use of indoor GML, in fact, you can switch back to room, but also to subspaces, because you can subspace a room and defining sub areas, and those sub areas will have the geometrical representations. So that if you are in an airport and you are at the check-in area, and that's in CityGML is one room, for instance, then in indoor GML you can have extra geometries that define your subspaces, where you have a check-in desk 1, check-in area B, you see what I mean? Info point C, and those have a geometrical feature attached to it, which is a geometry that define a spatial property of it.
By the way, I think that it is important, in my opinion, to do not stress too much just on a, let's say, philosophical dimension of this indoor versus outdoor, because as we learned, we are continue learning from Inspire, the code list of the data model in general is suited to satisfy some use cases, some user needs. So these recursive segmentation of indoor spaces, I think it's quite easable from a data modeling point of view, but we should start from some, as iLocate is providing, from some general specific use cases, like find a point of interest in an airport or in a shopping mall. And so probably this complexity can also be lowered.
Indeed, I think that this sparks a philosophical but a technical problem at the same time, because if you don't qualify those spaces, then you are also unable to request for the location. For instance, imagine geocoding, a reverse geocoding in an indoor space. If you are within an outdoor space, you say street number, city, you have the location. What if you're indoor? Either you define it semantically and you say classroom, second floor, whatever, you have classroom, you see what I mean? Or how do you do that? So it's not trivial. I'm not saying that I have the answer. I do not have the answer right now. But what I sense is that there is a big requirement there from a technical point of view. And certainly what I sense is that the fact that we can have indoor location technologies is opening up the Pandora's box, basically.
Basically, because you mentioned before that in order to enable this kind of functionalities for indoor spaces, you need a graph. And this is Indoor GML who is providing that. Once you have a graph, even though you have no more the technology of the GPS giving you the exact position, we know many outdoor geocoding problems when you have not the strict numbers and the distance is just estimated from one node to the other and then interpolated in a linear way. Probably also in the indoor graphs, you have this less probably precision of the points, but at the end it is something that can work.
Yeah, but it's not as much a problem of precision. The problem is now the problem of searching. Because we all know the problem of geocoding, reverse geocoding, the problem of addresses. I remember there was URADIN, the European project just on addresses. They can be very differently defined in different countries and so on and so forth.
But probably it's important also to speak about ontology.
That's the point. That's where I was getting to. The problem is semantic here. Because otherwise you're not able to find.
Hospital are different museum,
exactly.
Public building, quality.
Exactly, and the point is that when you do indoor navigation, you have the problem that a classroom is always a room, so you should be able to find it whether you're looking for a room or whether you're looking for a classroom. So probably that's one of the examples where the semantic approach becomes more important probably than in other cases.
Do you think that similarly to CityGML that we have the application domain extensions, we can have something like that in Indoor GML? So we can define data models specifically for each use case, such as a hospital or a school or anything.
Well, right now the way the standard is done is that it lets you tag sort of the spaces or the cells, but it does not provide a way of structurally defining those tags, if you know what I mean. So it's very flexible. It says, okay, tag it, however you want to tag it. But that's the point. How do you tag it? It's not a matter of being difficult. It's very simple. It's just a word or two words. The point is, how do we agree on those words that have a meaningful way of doing them? That's a very tricky and crucial point at the same time.
But which are the OGC directions to? Right
now there isn't. Right now there has been lots of attention on how to define the standards. So the big skeleton. Probably this will be something that will emerge as soon as there will be an implementation. By the way, iLocate will become the first implementation of Indoor GML as a standard. So I'm sure that once we get it kicking and running, this problem will emerge. But so far, the problems have been the groundings, the real building blocks of the standard. We haven't got to that point yet, but it's there. I mean, the problem is there. And it would be interesting also to use the experiences of other projects in the outdoor domain to possibly leverage on this. Again, I'm not saying that I have the solution, but there is a problem.
Anyway, is there a SWIG, a standard working group?
There is a SWIG, which is the Indoor GML SWIG.
Recently established, or not?
That's pretty, well, a few years now, a couple of years probably. And that's the SWIG that is in charge of releasing Indoor GML.
And LBS established
and we have the liaison with the SWIG. So we will provide feedback to the SWIG, develop things for the SWIG, and so on and so forth.
You are a member of the SWIG?
Yeah, I'm a member of the SWIG. And another interesting point, for instance, is the liaison with CityGML for obvious reasons. But again, there are dark areas which haven't been addressed yet.
I was thinking that it will be very complex, for example, to attach tags to rooms in a hospital. Mostly building upon what you said, with rooms being open for some periods of time or for some different people. Because a hospital, usually big hospitals, regional hospitals, and so on and so forth, they're very complex structures, and they do have the rooms for the patients, but they also have some separate rooms which are which can be accessible or not based on the level of clearance for the doctors. They can be accessible for the patients, like the X-ray room, but just with the doctors. or just if some certain conditions are met. And there are rooms that are just accessible to visitors between these and these hours. So there's a lot of conditions to be met for your route to be displayed from point A to point B if you are a visitor, if you're a patient waiting to be examined, for example,
Yep.
or you have a certain area in which to go, or if you're a medic, the director of the hospital, different levels of clearance at different types of day.
Yep.
This is another point that has to be considered, and maybe these tags will also have to have this category of accessibility based on your person, what you represent for the building. For the
Not only person, but again, as I mentioned, it could be robots. For instance, now several hospitals, maybe some of you do not know that several hospitals run robots to bring things these are of course in enclosed area that we don't see as visitors, but these robots are used, for instance, to bring medicines or to bring all the equipment that is needed. We have one, for instance, an hospital in Bolzano where they use those robots. And indoor GML, for instance, has been specifically also designed, and it will be extended to provide support to robot navigation, for instance. So again, the requirements can be a lot. Georgia, I would like to know from your standpoint instead, what do you think we do know and what do you think we do not know? You're an expert in training, and here it's all about things that we do not know. So where is your priority list?
Well, it's very difficult to say what we know and what we don't know. So just coming here, I learned even more than what we had in the discussion and kickoff and the first meeting. So it's extremely interesting how much this the indoor location-based service can open the door for many applications. For sure, the not technical people, so the stakeholders, those that have to use this technology, that's not much. We have to say that they just start. If we speak, for example, in the people in the public administration, they just have now the familiarity with JS technology and Inspire. Now they are in confusion what they have to do and so on and so that there is really a lot to do to know about this. For sure, there is different technologies, and that is something that they have to understand. Maybe the difference between Wi-Fi and the other technologies that give precision. First, they have to know which are the requirements. Exactly, they have to understand the requirements itself. We learn, for example, we learn because we were in the meeting in Malta when we had the last meeting that the geometry of the building, of the room, the different type of construction, if there is which type of wall, if there is some metal inside the wall, affect this technology. So it's something that anyway they need to learn what is behind this technology. And on the other side, I believe that also the technology provider has to learn a lot about this type of requirement. What is the problem of the different public administration? So indeed, there is a lot for learning, and so most is what we don't know, what we know for sure about that. So I think that there is a lot to do, and training will play a very important role in this.
Good for you. He's the training man.
Sort of training framework that can bring all together all these main issues. We didn't speak yet, but for example, the legal barrier is just the problem of privacy. So it's just giving some location-based from one person that enters the building. So the privacy, we are authorized, we are not authorized.
If you're interested, there is, by the way, if you're interested, we have made an analysis of all the legal framework of privacy and security in terms of location, and it's publicly available from our website. All the deliverables are public, so you can go and look for them if you're interested in that.
So that is another topic that also we have to know about what is the thing. Indeed, we are building a training framework that take in consideration which has different technology, the architecture constraint, and also the legal framework for doing that. So it's
Giacomo.
very interesting.
SMEs.
Okay. I think that starting this project, we already discovered more or less the same context that after 2 years of this Minspire project, more oriented in the general geospatial sector, we found that there are SMEs are playing. So there are two main categories. Some SMEs also in this project, very expert. They are leading technologies. They are providing solutions. So they are at the quite top level. And we heard about acquisitions from Nokia. You mentioned the spin-off.
Yeah.
So they are playing an important role. But there are a lot of SMEs who are not aware, and I think we should address them in terms of opportunity, because just taking some notes from the business part of the UW that you wrote, there are very interesting numbers, because there are compound annual growth rates of 30%, which in this period of crisis is very promising. I don't know exactly from where these numbers were taken, but they are the global location-based market seems to be in the range of hundreds of billions. So extremely interesting. So I think that for the SMEs not aware, we should address for the SMEs already working in the geospatial domain, to increase their awareness, also thanks to the training, to the dissemination about this new indoor dimension. But also for new entrant SMEs can be very interesting, because the mix of I think they can play a key role in all the components, in the data provision, in the hub, in the service, and also in the pilot part. And
yep.
Indeed, we have to establish some mechanisms, because we know that many SMEs want to enter.
Yeah, I mean, to be honest, we have started this project 6 months ago. We are now finishing the system design, and from July the 1st we'll start with development. And I can tell you, every second or third week I am contacted by a company, and it's often an SME or a startup doing location-based services. They are interested in the standardization process. They want to join forces. So it's a very, and we haven't started yet, so to say, the development in the pilot phase. And already every 2 to 3 weeks there is a contact from a company. So from my standpoint, I can feel that there is, the pressure is rising there. Yeah. So we need to help streamline, and I'm not sure how we're going to involve those SMEs right now. The open environment, that's a discussion that we will have to address sooner than later.
Yeah, at the moment, they have to say that for a new entrant, the business model is not so clear. So because there are still some barriers that we already envisage to overcome, but it can come up soon.
Any comment from your side? I think it's 10:30, so we are.
Do you consider using 3D files for massive scale to represent indoor architecture?
Not yet. Again, as I said, we'll rely on CityGML. So if it comes from LiDAR or whatever, we'll have to boil down to CityGML first. But again, the problem is that this domain is moving so fast. And Google Glass, it's coming, and everybody will be used to have goggles in a few months, probably. Tango is coming. I don't know if you have seen Tango, but I encourage you to go on the web and search for Google Tango. and you will see what this is about. It's again LiDAR indoor basically, and it's surprisingly accurate the way they do it.
Yes, it was about privacy. Who is supposed to give the right to publish data? The building owner, the building occupant?
Privacy is a big problem. From the legal point of view, let's say we have made, first of all, the first thing we have done was a legal analysis of all the legal framework across Europe. So for the legal point of view, first of all, what we do is that we anonymize completely data. So we never know, basically, the system never knows where a single person is. I mean, it knows that the human being is there, but the system doesn't know that that human being is called Giuseppe Conti. That is something that has to be granted. So what we do is we anonymize the data. We make sure that wherever personal data are stored, location data are not stored. Giacomo, you want to?
Yes, I think that particularly for the question, I think that we will start with public indoor spaces.
Or public accessible indoor spaces. There are secure areas at the airports or secure areas in the hospital they do not want to disclose. So in that point, the map will not have a room. It will be empty in that part.
But the owner has a choice, yeah?
The owner is free to upload whatever data they want to. I mean, the open space is open anyway. The public area is public anyway.
One knowledge is when there's such a space, even if it's like...
Sorry?
Oh, one entity, one person acknowledges some terms of reference when they enter such a place.
And there is another point. I mean, the public portal will be providing access to open data to the public, but no one prevents you, for instance, as a manager of the hospital, to download, iLocate, install it on your servers, and run your own iLocate infrastructure with your own database, with all the data that you want, because maybe you are only addressing doctors. I think
so if the app comes out, what's the first thing you will use it for? As a user or as an SME or any ideas?
Probably the mall.
The mall?
The mall, yeah. It's difficult to navigate.
By the way, we are opening a challenge. I will be launching it in the remainder of this week. The iLocate challenge, and it will be a challenge that will be awarded for the best idea for indoor and outdoor location-based service. You will know about it. Yeah.
Just one question. Are you in contact with fire departments or?
With fire departments, not yet. No. If you
especially if there is a fire,
yep.
Locate and navigate
yep.
inside.
We have one example. One of the pilots, the one in Genova, for instance, will be about emergency routing. So there will be the emergency staff of the building, not fire brigades, but the emergency in charge of the staff in charge of emergency will be involved.
Also to track maybe visible people that are inside the building.
Yeah, but also if there is smoke, they cannot see anything.
Yeah.
The complex building.
Exactly.
Like
our hotel.
If an emergency will come, probably will trigger a directional path out. So they will have the other doors closed. They will just have one path, the quickest path out. That's safe.
But as you can see, it's a very complicated world. So we are opening Pandora's box. We will provide a small solution. The most important thing is that it will be, again, based on standards. So it will be reusable, but the problem is still there. I think we're done. That's it. Thank you very much.
Thank you.
Thank you.
Yeah.